Welcome back. Today, what I want to do with you is actually go through a typical limiting reactant problem that involves masses only. So we've worked our way up from the dance analogy to basic understanding of mole ratios and balanced equations. The next step is to say to ourselves, what happens when we have masses only at the beginning, and can we figure out the theoretical yield of a product? And the answer to both those questions is yes, we can. So I'm focusing on question number 2, which is on page 334 of your textbook. It's always a good idea to have your periodic table out and, of course, your calculator. That will allow you to follow along to see what's really going on here. So here we go, number 2 on page 334. If you look at this reaction, if we take 2 moles of iron and we react it with 3 moles of chlorine gas, which is pretty dangerous, not something that I'm going to do in the lab, to be honest, we make iron 3 chloride, which you have seen before. It's an orangey solution, not real soluble in solution. We've got our balanced equation, so our equation line tells us for every 2 moles of iron that we have available, we require 3 moles of chlorine, and we're going to make 2 moles of iron 3 chloride. In this particular question, they're giving you 2 different masses of reactants, and that's a little bit different. So we're given 5 grams of iron, 5.00 to be exact, and we're given 9.00 grams of chlorine. And the first step in the problem, even though it doesn't say this necessarily, is to find out which reactant will run out first. Is it the iron or is it the chlorine? Well, we've already done this in the past. You know how to find moles from grams. So we plug in our equation. The moles of iron available is equal to grams over molar mass. So that's 5.00 divided by the molar mass of iron, about 55.85 grams per mole. That gives us a pretty small number. It's decimal 0.895 moles. Now, when we look at the chlorine, you can see a similar process. We take our 9 grams that we start with, divided by the molar mass of Cl2. That gives us 0.127 moles. And you might be tempted to say, based on those results, that the iron is a limiting reactant. It's very tempting because this number is smaller than this number. But don't trust short chemists. Do the math. The numbers don't lie. The best way to show whether iron or chlorine is indeed the limiting reactant is to do our handy dandy check. And that check is what I put in the box. If you take the experimental data and divide it by the equation data and figure out the ratio, you can see that 0.0895 over 2 is about 0.0445. Likewise, 0.127 over 3 is 0.042. So very interesting. When you look at it closely, the decimal 0.042 underneath the chlorine is just a little bit smaller than what we got for the iron. So, at the end of the day, we can decide that the chlorine is a limiting reactant and the iron is in excess. So I'm going to put that right above. There's our LR, or limiting reactant, above our chlorine, and the iron is in excess. Furthermore, because the iron's in excess, we can put a big old X right through the moles of iron that are available. Why? Because you know that the excess reagent is no longer important because it does not determine the overall yield of a reaction. It's the limiting reactant that does that. So this number becomes very important, the 0.127 moles of chlorine. Good news now is all we have to do is look at our mole ratios to figure out the theoretical yield of iron 3 chloride. And of course the theoretical yield is what we calculate. We don't have to do the experiment to figure this out. So, according to our balanced equation, for every 3 moles of chlorine we have available, we're only going to get 2 moles of iron 3 chloride back. So it stands to reason that the moles of FeCl3 that we should get back will be less than 0.127. That's why we're going to multiply that number of moles, 0.127, by 2 over 3. Because the 2 is what we need and the 3 is what we have. All this is a ratio, kind of like a fraction that allows us to figure out the moles of the product that we should get back. And we'll get 0.085 moles of iron 3 chloride. That doesn't mean a lot to a chemist until we convert it to grams, because our balance is weighed in grams, as you know. And we use our mole triangle at the very end, and we can figure out quite easily that 0.085 moles of iron 3 chloride times the molar mass of FeCl3, which is 162.4 grams per mole, gives us 13.8 grams of product. So we can finally say that the limiting reactant in this problem is the chlorine. The iron's in excess, it's no longer important to us, and because of the limiting reactant being important, we can calculate our theoretical yield, which we decided was 13.8 grams. And that's all there is to it. Your very typical limiting reactant problem. Our next step involves looking at the yield of a reaction. So this is what we get in a perfect world. Because we're human, none of us is perfect. We don't do things perfectly in the lab. We will go through some problems and determine what we call percent yield and actual yield. Hopefully this helped. Try the problems in the textbook. Read my PowerPoints, and certainly pay attention to my videos, and all will be good for you.